Hello guys, and welcome to this new video in the OpenGL series. Hope you guys are doing good. In the previous video, we've learned how to draw our first rectangle. The idea was to make use of two triangles to actually achieve the task, because what we can basically do in OpenGL is draw triangles. So there is no way we could simply go out and draw a rectangle like that. We need to trick it a little bit. So we made use of element buffer to actually achieve the task. So if you guys don't know what I'm talking about, I think you really want to go and check the last video. I always provide the link in the description below. In this video, we're going to be moving forward and draw a texture on top of that rectangle. This is not an easy task because OpenGL does not provide any way of loading textures. So we need to maybe build our own loader for texture, or maybe use one which is already out there. But anyway, we still need to include something in our project to be able to achieve the task. Our game engine series is coming soon, and if you guys don't want to miss any of our uploads, make sure you hit that subscribe button. You like this video also if you find the content interesting, and yeah, share with your friends if you think someone will want to learn OpenGL too. So let's get started. Drawing textures in OpenGL involve a lot of theoretical things that we really want to talk about, because this will make our job easier as we start using texture over and over. The first thing we want to talk about here is the texture coordinate system. The texture coordinate system actually defines how you want to use the texture. So you can see right here we have our texture coordinate, which will be referred to with S and T for the X and the Y axis. Keep in mind that we're talking about 2D textures. The center of your texture coordinate is the bottom left corner of your texture. So if I want to draw this rectangle right here, I'll have to specify each corner of this texture, and the GPU will then know that I'm actually taking from here to here, and whatever, just the whole surface. That's the idea. So it might also happen sometime that you want to take just a specific part of the texture. Let's say you want to draw like a tile map, and you have a tile set, and you want to take a specific part of that tile set and draw it on the screen. This is actually the reason why we have texture coordinate. OpenGL actually load texture from bottom to top, which means you need to add an additional process in your loading process to actually invert the y-axis, because you will have your texture drawn in an inverse way. So that's quite important to know. The next topic is to talk about how we're going to be loading texture, because if you remember, there is no way in OpenGL to actually load a texture. There is no function that you're gonna call and just get your texture loaded in the memory. I think it makes a lot of sense to build one, but since that's not the topic of this video series, we're not gonna be building one ourselves. But I think later, when you get confident in OpenGL, I will recommend you to go and try to build your own, and maybe just to improve your programming skills. But we're going to be using the well-known simple OpenGL image library, aka Soil, which is quite good. Using this actually involves downloading it, compiling it, and linking it into our project. And that's the next topic of this video. To actually be able to compile the library and use it in our project, we first of all need to download Premake, because Premake is like a simple program which will help us generate a Visual Studio project for the source code of Soil, so we can actually compile it and generate a lib file. So you will find all the links in the description below. You can download the latest version of Premake, like the 5.0 here. Just download it and you'll be able to actually use that. And the next thing is also download Soil. So I'll provide a link in the description below so that you guys can easily download that. Once you've downloaded these files, you will normally come with 2 zip files, as you can see right here. You simply have to go out and extract them. This is a trivial task, you already know that. You extract both Premake and Soil. Now you see, when you extract Premake, you will get this access file right here. So I want you to copy this, or cut it, whatever, and paste it inside of Soil. You want to open your command line, your command prompt, or whatever you call it. And one thing you want to do is you want to change directory. You want to go inside of this directory right here, and one way of doing that, instead of writing all this path, you can simply go and grab the folder like this and put it here, and simply push enter, and you will just write inside of that. So since we're inside of that, we can access everything which is here. So I want to call Premake 5 Ep.6, and we're gonna be doing this for Visual Studio 2012. I haven't tried if you can do it with newer version, because I know Premic didn't have newer version of Visual Studio, but it doesn't matter, this always works. You just push enter. This will generate a Visual Studio project for us, which has been made, and you can see here we have a new folder called make, and in there you go to window and you can see we have a solution, a Visual Studio solution. So go out and open that. So you will be asked if you want to update this project, which is something you want to do, so you just click on this button. Okay, so you have the project loaded. Now the only thing that we're interested in here is this soil lib, soil static lib. So the rest we don't care about. The rest you want to click right on this one and build it. So this will take a couple of time and you should get your file, your project built. So you see we have a success, you know, everything was right. You want to close the project, we don't need that anymore. And if you go back in your soil, you can see we have a lib here, and in there you find the lib file that we want to do. The next step which I want you to do is to actually, you know, link this in your project. So you go to your project in Visual Studio, and there you want to open the Explorer and whatever you want to open your project file. If you remember, as we have been setting up glue and glfw, we've created all these folders. So you want to create another folder for soil, as I did right here. In that you will have a folder for include and another one for lib. In the lib folder you will simply copy the lib file that I just showed you. So you want to go and copy this lib file inside of your lib folder here, and you want to do the same thing for the, you know, include folder. You want to copy south, you have the soil, you want to copy this in the include folder. So you make sure you copy both of these in your soil folder in the project. So you have the lib and you have the include. So now you have it, you know, beside your project, and I'm tired. Now that we have soil linked properly, we want to go out and include that in our project. Now the shader have changed, but we're going to be talking about that in a couple of seconds. I'm not going to be using this to explain because this is quite unreadable. I'm going to use this instead, which is something we're going to be doing. So now you want to define a function which is going to be used to load our texture. So it takes a char pointer as parameter, which is the path of your texture. From here nothing has changed, so don't worry about that. I'm just going to be talking about the vertex data that has changed. Now we don't only have the position as vertex, we also have for each vertex the texture coordinate, which specify in this case each corner of our texture. Keep in mind that you can use any texture for this, it doesn't matter, you can grab anything online if you want to. Now the element buffer hasn't changed, so there's nothing I have to mention about that. But since we have changed the vertex data, we also need to update our, you know, vertex attribute pointers. We need to add another attribute at the location 1, which has 2, you know, element or 2 component. These are floats, and you see the stride is now at 5. We have to move 5 float to get to the next vertex. That's why we say 5 size of GL float. And the first index is 3 because we have 0, 1, 2, and then 3. You want to keep that also, because if you don't do that, you're gonna get some crazy errors and things like that. So, and we're gonna go down to our load function before we see how we draw that. The first thing you need to do in OpenGL while loading a texture is to, you know, allocate the memory on the GPU, because we're gonna be loading this to the GPU. We're not loading this in our CPU. This is actually in the GPU. So I'm simply telling OpenGL, okay, go out and allocate some memory for me, or maybe, you know, make sure there is something that I can use and give me the handle for that. And this is our texture ID basically. And now you want to activate that memory because you want to use that. And you can see the target is a GL texture 2D, because we have others target for textures like cube maps and, you know, 3D textures and things like that. But in this case, we're using a 2D texture. That's why we're passing this target. And you can see down here, this is where soil comes in the game. We simply use this function soil load OGL, load OpenGL texture, and simply attach the result to this texture ID. And as you can see, I need to add this flag right here to tell OpenGL to invert the y-axis, because If I don't do this, then my texture is going to be inverted, and I don't want that. So, and I just use this assert right here to make sure the job was done, because this function will return this texture ID if the loading process was successful. That's why I'm saying, okay, if this is equal my texture ID, then everything was correct. So this is just for debug purpose. You don't have to put this, but I would recommend you to do that because you would at least know where the problem came from. So, and now we have some parameter here, which I'm not just going to be talking about like that. I'm going to be switching over to my presentation to actually talk properly about this. The first parameters type I'm going to be presenting in this video are texture wrapping parameters. These parameters actually specify how OpenGL is going to react if the texture is not filling the space it was intended for. So you can see we have GL repeat. This will simply repeat the texture. GL mirror repeat. This actually will repeat and mirrors it. Clamp to edge will stretch the texture to fill the space, and clamp to border will fill the space with the empty space with the border color, basically. So that's the first parameters. And then we have the filtering parameters. This actually define how the sampling is going to be done. Sampling means how OpenGL actually get the color from the texture to the vertex. Because if you remember in the video where we have been drawing triangle with one single color, we have been setting the color of each vertex. That's the same thing here. OpenGL will simply go on the texture and grab a specific color for each fragment and then set that as being the current color of the vertex. And so you have two ways of doing that. You can either use the linear interpolation or you can use the nearest. Linear interpolation means you're going to be taking the color of these guys here and interpolate that linearly to get the color of this fragment. And the nearest will simply take the one who is as near as possible from the fragment. So basically in this case this will be the yellow one. Using MIP maps will increase the performance of your program in the sense that this will generate different size of your texture, and when the object you're drawing right now is maybe too far away from the view position, then you will use a small size, because you don't want an object which is like 1,000 miles away to have the same precision as an object which is right in front of you. That will be like a waste of performance, and we don't want to do that. That's why we also want to generate MIP maps so that OpenGL will always use the texture that fits the most for the current object. So that's basically what you need to know about loading textures. So let's switch back to the code. So you can see right here how we actually loading our texture, how we set each parameters, repeat on the X and the Y axis, the nearest if the object is near, and if the object is small, you want to use the nearest. If the object is far away, you want to use the linear interpolation to get a better result. So that's basically it here, and we generate the MIP maps and we unbind our texture. The last thing we've left to do is to draw the texture. OpenGL actually has the so-called texture units. I think this sometimes depends on your graphic card, but you basically have like 16 units, which is where you can actually attach texture into to be drawn. And keep in mind that you cannot draw more, you cannot attach more than what your graphic card has as number of units. That's something you want to know. So you can see this is the default unit. I don't even have to activate this, but because I wanted to talk about this, I just show you. I'm activating the first unit, and the unit I just specify using GL texture 0. This is the unit 0, which is the default one. I don't even have to write this line, as I said. And now if I want to draw my texture, I want to bind it. So we've called this function here to load the texture. I want to bind the texture, and I want to send the data to the shader, which leads us to talk about the shader. The rest here is just the same. You want to just unbind the texture later. Now if I switch over to the shader, which is the code we have up here, I'm just going to show you here so that you guys can maybe write it or correct whatever you have in your. If you remember, we've sent our attributes. The first one was the position and the second one was the texture coordinate. And down here we simply define our color, which is going to be the output. And you can see we use a uniform. We talked about uniform in the previous video, and as you can see down here, we're sending the texture, we're sending this uniform to this sample texture, you can see, using this program. And we're sending 0 here because we activated this guy here. This is the unit. This is not like we're sending the whole texture. No, we're just sending the unit in which the texture is currently bounded. So that's why we're sending 0. If I had 1 here, then I had to send 1 here. So that's basically the idea. And so you can see here we have our sample texture, which is this guy we're sending here. And we're sending the unit value. We have it, it's called sample 30. This is a type of that kind of the textures. And we basically have this function is OpenGL, which will go and sample for each fragment the color using the parameters that we've set before, GL nearest, GL linear for the interpolations and things like that, to get the current color of this fragment. So up here we have the vertex shader, and here we have the fragment shader. This is basically how you can draw the texture in OpenGL. So if I run this, you will get your texture on the screen. Now I've been using like this rock texture, but as I said, you could use any kind of texture, it doesn't matter. So I can remove this, and you see this will still work because this guy is the default unit that OpenGL uses to draw things, so this doesn't change anything. But if I put like 1 here and run this, because I'm sending 0 here, this should normally not work. I haven't tried that, but you see it's just throw an empty. But if I put 1 here, I'm just telling it go to the unit 1 and grab the texture ID you got there. Oh, I changed, this is wrong. This is 0. I'm not in the right function here, up here. Then I can simply run this, and you see we're going to get the texture on the screen. So this is basically how you can draw a texture in OpenGL. I know this is a lot, there's a lot going on, we need to define this and that, but once you get this, you will never have to do this again, and you only have to implement this function once, and you will always use that. And that's basically all for this video. So thank you for watching. I hope you guys learned something. If you did, leave a comment below if you have any question or any concern, anything like that. Keep in mind that our OpenGL game engine series is coming soon. I just wanted to show things like this because I'm not going to be spending time trying to explain this as I start the game engine series. So that's why I want you guys to know this. And you know, that's all for now. Ciao.